Fisheries are worth an estimated $246 billion to global economies, with over 95% of fisheries being found in coastal areas or areas of upwelling, with population expected to rise to 9.7 billion by 2050, and fish providing 40% of the population with a good source of protein. The current problem with fisheries and their management needs to be addressed.
Over the last 25 years, a great number of fish stocks have been overfished and depleted, including the well-known North Atlantic cod, bluefin tuna, as well as a wide range of other demersal species. So how does this happen? Well, this can occur when the fishes reach a high catch per unit effort. A decreasing catch per unit effort within a fishery can indicate to overexploitation of that fishery, whilst an unchanging catch per unit effort suggests a sustainable harvest. Fishery management can be split into two stock topics: the assessment of the stock and the harvest of that stock. With increasing fleet size, catch unit, all fish, old and young, caught will soon enough lead to an overexploitation and a collapse within the fishery. So how do you monitor stock and harvest? Models of harvest and stock assessment have been developing over the last 25 years, from surveys to statistical analysis. From 1985, harvest rules and stock assessment were very, very basic, and in some fisheries were not even in place. Since then, over the last 25 years, stock assessment models have been made, such as statistical catch at age, SCA, and statistical catch at length, SCL.
Maximum sustainable yield, otherwise known as MSY, is the largest yield that can be taken from a stock from an indefinite period of time. MSY has long been used as an indicator of fishery stock health all over the world. The problem with MSY is that it ignores several key factors which can cause collapse of a stock, and scientists have spent a long time trying to ascertain a more appropriate way to monitor fish stocks. The problem with MSY stems from the initial predictions. The model is only an estimation and does not account for real-world events, such as predation on fish eggs and larvae. Upwellings would have a huge impact on fish stocks, but would not be accounted for in the MSY model. Additionally, each species of fish is different. If a fishery changes its catch species or age cohort, MSY will not account for this, as different age fish responds differently to catch effort than other age cohorts. In a paper by Christensen in 2010, the problems with MSY were identified. Working at MSY is working at full capacity, and often MSY can be wrong, as it is only an estimate. It is estimated that $3.2 billion could be raised in profits if the MSY was no longer used as an indicator for fish stocks, but we instead use the maximum economic yield, or MEY, as the sole indicator for stock models. When all fishing effort is exerted and it exceeds the MEY, there are negative societal implications such as unemployment and depression. With fishermen selling produce at a static price, but restaurants able to manipulate final goods prices, there is increasing pressure on fishermen to fish above and beyond the maximum sustainable yield, leading to poor stock predictions and overexploitation.
It has been suggested that the key ingredient to a successful fishery is through the management of people. Over the years, we have seen many sea ecosystems break down and fishing industries collapse, all mainly due to humans overfishing. Therefore, if the world's fisheries want to move towards a more biological, economic and social sustainability, then the understanding of fishermen's motives and the creation of a management regime which acknowledges social objectives needs to be implemented. Managers of fishing fleets set annual catch limits through total allowable catches in the hope that this will aid the impacts of overfishing. However, this just leads to a competitive race for fish scenario. This then creates an unsustainable way of fishing and has left many domestic fleets in the USA and elsewhere to expand beyond the level needed. There is not one solution to fix fisheries, as solutions will vary depending on their situation. One point to make, however, is that there needs to be a more focus on social objectives to provide the route to high yield, employment and the maintenance of a healthy ecosystem.
Fisheries management is difficult because it involves balancing competing biological, economic, social and political objectives. Conflicts arise among fisheries stakeholders due to differences in power, interests, values and priorities. Institutional failures in managing fisheries and enforcing laws and regulations are also a source of conflict. For these reasons, the top-down, bureaucratic and science-based approach to fisheries management is often criticised. Governments have repeatedly failed to prevent fish populations from overexploitation, and in many cases have even exacerbated the problem through mismanagement. Fishers do not usually readily accept government impositions, and there is increasing recognition that fisheries cannot be managed effectively without the cooperation and participation of fishers to make laws and regulations work. This has led to increased interest in community-based co-management. This involves the sharing of responsibility and authority between the government and the local fishing community. This allows government researchers and local fishing communities to work together to achieve the common goal of maintaining healthy fish stocks. It may also improve compliance among local fishing communities, as people are more likely to support and follow rules that they have decided on themselves than rules that have been imposed upon them without choice. However, healthy fish stocks are a collective good, and in common property situations, opportunistic behaviour is often tempting. This may lead to fish population declines through a process popularly known as the tragedy of the commons, in which individual users in a shared resource system act independently according to their own self-interest, leading to the decimation of the resource. If an individual had sole access to a fish stock, it would be in their interest to limit their catch rates so that populations would remain stable and able to regenerate in the future.
Fishing effort and yield have been increasing exponentially since the 1950s with the end of World War II and the advance in technology. However, the increase in catch efficiency and increasing demand for food led to many fisheries to collapse. These collapses in the North Hemisphere led to exploitation of underdeveloped tropical fisheries to maintain the fish supply to the developed countries. Fisheries management strategies implemented by developed countries are shifting unsustainable practices in poorer nations that have less management capacities. In developing countries, high-value fish is often exported, reducing the amount of animal nutrients accessible to the population. However, the income generated from fish exports enables these countries to purchase food staples. It is difficult to resolve the trade-off between fisheries management, conservation, and socio-economic stability in developing countries where families rely on fishing and its products for their livelihoods. The existing trends predict that food instability is going to increase because of fisheries conflicts. Declining fish stocks and increasing human population, investment of developed countries in fisheries of the south of the world, increased consumption of fish by developed countries, and increased reliance of coastal community on fish product is bound to increase food insecurity, especially in poorer nations.
One of the most controversial aspects of fisheries is their ethical impact upon the fish themselves. This is due largely to the much debated argument of fish sentience. Are they capable of A, feeling pain, and B, of suffering? Many studies have been conducted, though results often conflict. It is likely, however, that at least the bony fish have the biology necessary to experience pain. They possess a nervous system and nociceptors, and have been observed reacting to touch and pain stimuli. If this is so, then it can be assumed that fish can suffer from physical and potentially mental injury. Many fish farms are forced to supplement their stocks with wild-caught animals, and while attempts at captive breeding have met with a certain success, this raises concerns of its own. Breeding behaviour is stimulated through the administration of hormonal injections. For species such as salmon, which in the wild state have complex and specific breeding cycles, this practice is unnatural in the extreme. Many methods of fishing raise various ethical concerns. Beam and otter trawling cause high mortality among local fish stocks, in addition to the destruction of seabed habitat and the indiscriminate trapping of multiple species, target or otherwise. Furthermore, there are to date no large-scale fishing companies who adhere to a humane and ethical method for destroying the fish they catch, instead dumping them on death to slowly suffocate.
Fisheries management is complicated as there are many stakeholders involved. It is difficult to balance the different economic, social, political, biological, and ethical interests of the parties involved. The solution must be searched in the trade-off between these interests.